Welcome to Math with Professor V. This video is part of the new series Algebra Review for the Calculus Student, and it's part 3 on factoring and limits. So we're going to go over now generally how to know which factoring technique to use. If you didn't watch the first 2 parts of the factoring review, they're linked in the description. But now we're going to go through a strategy to utilize anytime you need to factor, so that way you know which technique is appropriate. So the absolute first thing you need to do is factor out the GCF, the greatest common factor. Make sure you do that, because then each of the other techniques will fall into place, having taken care of that. Then the next thing you need to do is count how many terms you're factoring. So count the number of terms in the expression, and that will tell you what procedure is appropriate. If there are 4 terms, 99% of the time, you're going to factor by grouping. I did show an example where there were 4 terms and we had a perfect square trinomial and another perfect square, and it ended up being a difference of squares, but that's so rare. So just be aware that that comes up on occasion. Okay, if there's 3 terms and you're factoring, then be on the lookout if it's a perfect square trinomial. How would you know that it's a perfect square trinomial? It would have the form a squared. The middle term would either be plus or minus 2ab, and then the last term is plus b squared. And then from there, it would factor into a, either plus or minus b quantity squared. And these signs always match. So if it's a positive 2ab, you'll have a positive b here. If it's negative, negative. Next option, if you're factoring and there's 3 terms, is if you have a quadratic expression, x squared plus bx plus c, then it's going to factor into 2 little binomials, basically x, x, and then you have to figure out what constants go here. Remember, those constants need to multiply to c and add to b, but you can just factor straight away once you've identified 2 constants that satisfy those conditions. It's a little more tricky when your quadratic expression is ax squared plus bx plus c, and a is not 1. That's when you can utilize the AC method that I showed, where you split the middle term and then factor by grouping. You also can still do trial and error. So I'm going to list that. Trial and error is more efficient time-wise, okay? I like to save the AC method when there's just too many options for trial and error. So it's good to know both. Definitely good to know both. Other case now is if you have 2 terms that you need to factor. So let's review. If you have a difference of squares, a squared minus b squared, it's going to factor into a plus b times a minus b, conjugate pairs. If you have a difference of cubes, I shared with you the mnemonic to remember the signs. So same, opposite, always positive. Just think soap. AB, a squared, AB, b squared. And then similarly for a sum of cubes, a cubed plus b cubed, it'll factor into a plus b, a squared minus ab plus b squared. Lastly, if you have a sum of squares that doesn't factor over the real numbers, that's prime. Okay, and then this third little reminder here is just be sure that you factored completely, because sometimes after one round of factoring, a new one arises, a new situation. So just keep scanning and make sure everything's completely factored. So we'll work through just some general examples and then use it to find limits of functions, since we're in calc now. Okay. Example A, factor completely. We have 10a squared minus 640. Well, first things first, we're taking out that GCF. What is it? It's a 10. Very good. So I'm taking out a 10, and then you have a squared minus 64 left. Are we done? Oh no, we're certainly not done. This is a difference of squares, 2 terms, difference of squares. So it's going to factor into conjugate pairs, a plus 8 times a minus 8. And then we're done. Now it's completely factored, so we'll box that answer. All right, good. Next example. Is there a greatest common factor I can take out? No. So then I'm like, okay, I'm ready to proceed. I'm counting it up. There's 4 terms. So let me factor by grouping. The greatest common factor for x cubed and negative 5x squared is x squared. If I take it out, I'm left with x minus 5. Then I bring this minus sign down. And then the greatest common factor between 25x and 125 is 25. And then watch out, I have to switch this to now a minus 5. Since I'm factoring out negative 25 from positive 125, it becomes negative 5. If you forgot to switch this to a minus sign, you would have noticed you were in trouble anyways, because remember, when we factor by grouping, these 2 factors need to match exactly. So if this one had a minus sign and this one didn't, then you'd be stuck again. So it kind of catches you when you make a oopsie. Okay, so now I'm going to factor out this x minus 5, and then I'm left with x squared minus 25 as the other factor. Are we done though? Have we factored completely? No, we have not, because x squared minus 25, that's a difference of squares, so that can be factored further. So we have x minus 5 here, and then this factors into x minus 5 times x plus 5. And we could write our final answer as x minus 5 quantity squared. Just write it once and then put the 2 times x plus 5. Oops. Beautiful. That one's done. So see how sometimes when factoring you have to use multiple techniques for one problem to get it completely factored. All right, example C, 45 minus 3x minus 6x squared. The first thing I would say is put it in descending powers because it's not the easiest when it's written this way. You can still factor sometimes, but I think it's just harder on the brain. So I would rewrite it as negative 6x squared minus 3x plus 45. And then now we can take out a common factor. If the leading term is negative, I'm going to encourage you to take a negative common factor out. It just makes life a lot easier. You don't have to, but it will certainly save you quite a bit of headache. So I'm going to take out a negative 3 from everybody, and then I'm left with 2x squared plus x minus 15. Take a second. How are we doing? Okay, so now looking here, this is ax squared plus bx plus c. We could factor using the AC method and split the middle term. So when using that method, you take a times c, you put it up top. 2 times negative 15, that's negative 30. B goes in the bottom, b is 1. And you try to think of 2 numbers that multiply to negative 30 and add to 1. So that would be positive 6 and negative 5. And then from there, you split the middle term using those constants. So we have negative 3 here, 2x squared plus 6x minus 5x minus 15. And then you factor by grouping. So negative 3 times, I could take 2x out here, and I have x plus 3 minus 5 times x plus 3. And then now we're done. So I've got negative 3, I can take out x plus 3, and the other factor is 2x minus 5. Now, honestly, me personally, for a problem like this, I wouldn't do the AC method. I don't think it's necessary. I think guess and check works just fine. So I'm going to erase this and show you kind of how I think through it in my head, because guess and check is so efficient with time. So we have negative 3. I know it's going to factor into 2 little factors like this. And looking at the first term, since it's 2x squared, I don't have a ton of options to run through. It has to be 2x and x that get multiplied to give me 2x squared. The only issue here is the 15. So is it 15 and 1 or 3 and 5? And as I've said before, the majority of the time, it's the 2 factors that are closer together, unless this middle term is a really large number or a really small number. But I'm not going to try 15 and 1 most of the time. I'm going to try 3 and 5. So then the only issue remains, is it 3 and is it 5? Or is it 5 and 3 this way? And you just got to imagine it in your head. How am I going to get positive 1? This is 10 and 3. 10 and 3 can't be combined to give me positive 1. So that's not looking good. Now, what if I put it the other way around? 5 and 3. Then this is 6x, 5x. Yep, I can make 1x with 6x and 5x if this is positive and this is negative. And then I'm done. And the more you do this method, you'll get better at it. I don't even write out the options. I just kind of do it in my head. And like I said, when I was in school in my algebra class, they never taught me the AC method. All they told us was guess and check, you're on your own. So it's good to know both, but like you can see, guess and check's fast, right? Once you get good at it. Okay, example D, 64x cubed minus 27. Is there a GCF we can take out? No. So then there's two terms. It's a difference of cubes. Good. So A is 4x, cube root of 64x cubed, and B is 3, right? You could also write this as 4x quantity cubed minus 3 cubed, whatever you like. Then you can use SOAP to help you fill in the signs. So you're going to have same sign, opposite sign, last one's always positive. We have A, B. A squared, just be careful, it's 16x squared. Then A times B is 12x, and B squared is 9. And then we're done. You don't need to sit there and try to factor this trinomial. When you use the formula for a difference of cubes, as long as this wasn't a difference of squares first, then this is completely factored. This will not factor further. Okay? Good. Next one, E. P squared Q squared plus 7PQ plus 6. Don't get freaked out with the PQ. Just if you want to think of it like x squared plus 7x plus 6, and then replace the x's with PQ, you're fine. Yeah, this one's straightforward. It's just going to be plus 6 and plus 1, and you just have PQ for both of those leading terms there. Okay? Good. Good, good. Next one, 14x squared plus 19xy minus 3y squared. So is there a common factor I can take out? No. Okay. 14 is either 14 and 1 or 7 and 2. 3 is going to be 3 and 1. So this one you could probably guess and check just fine. If you want to do the AC method, though, we can. So A times C, 14 times negative 3, that's negative 42. And then B is 19. So can you think of two numbers that multiply to negative 42, but they add up to 19? It's going to be 21 and negative 2. So I'm going to use those numbers to split or rewrite that middle term. So now we have 14x squared plus 21xy minus 2xy minus 3y squared. And then now I'll factor by grouping. So I can take 7x out, and then I have 2x plus 3y. Over here I can just take out negative y, and then it becomes 2x plus 3y left over. Beautiful. So we have 2x plus 3y times 7x minus y. Do you think we could have done guess and check? I think so. Let me rewrite it. Look. 14x squared plus 19xy minus 3y squared. If you were going to do guess and check, first you focus on that 14x squared and you go, I'm not going to try 14x and x. That's too extreme. I'm going to try 7x and 2x. And then 3y squared, that has to be 3y and y. So it's just a matter of, is it 3y and y or the other way around? Well, we know it's the other way around. If you thought this one through, this is 7 and 6. Can 7 and 6 give you 19? No. So then you swap them. And we know this one works. This is 21 and 2. Boom. And then if you want it to be positive 19, you need the 21 to be positive. So you can still do guess and check, you know, trial and error, whatever you want to call it, pretty consistently. Okay, so now that we are little factoring machines, let's put it all together and evaluate some limits. So evaluate each of the following limits. We have the limit as x approaches 1 of x to the 4th minus 1 over x cubed minus 1. All right, so let's go ahead. Let's start by factoring the numerator. This is the limit as x approaches 1. The numerator is a difference of squares, so it factors into x squared plus 1, x squared minus 1. And then the denominator is a difference of cubes, so it's going to factor into x minus 1, x squared plus x plus 1. Now, we didn't completely factor the numerator because x squared minus 1 is a difference of squares, so that factors further. So we got to keep it going. So limit x approaches 1. In the numerator now we have x squared plus 1 times, this factors into x plus 1 times x minus 1. Then we have x minus 1 down here, x squared plus x plus 1. Perfect. So now I can cancel out x minus 1. If you want, you can rewrite this is the limit as x approaches 1, x squared plus 1 over x plus 1, or times x plus 1 over x squared plus x plus 1. But honestly, we can just evaluate it. So that step is not crucial. I can already just start substituting in 1 for x. So this is 1 squared plus 1 times 1 plus 1 over 1 plus 1 plus 1. So that's 2 times 2 in the top over 3. Good. Okay, let's look at some more examples. Did you factor that one okay? Here we have the limit as x approaches 2 of x squared minus 4x plus 4 over x to the 4th minus 3x squared minus 4. So again, this limit, like all the ones we've been focusing on, if I just try direct substitution right now, namely, if I just try to plug in 2, I get 0 over 0. So that's an indeterminate form, which means do something else. It's not time to do direct substitution. So let's start factoring. This is the limit as x approaches 2. The numerator, it's a perfect square trinomial, so it factors into x minus 2 quantity squared. If you didn't notice that and you just wrote x minus 2 times x minus 2, that's fine too. Now, x to the 4th minus 3x squared minus 4. Think of two numbers that multiply to negative 4 and add to negative 3. It's going to be x squared minus 4 and x squared plus 1. I have x squareds here because this leading term is x to the 4th, right? Okay, well, this is still not completely factored because x squared minus 4 is a difference of squares. So I can factor that further. So this is the limit, x approaches 2, x minus 2 quantity squared. I need a longer fraction bar. There we go. And then we have x minus 2, x plus 2, and x squared plus 1 left. So I can factor out this x minus 2 from the denominator with one of the x minus 2's in the numerator. And then now I just have the limit as x approaches 2 of x minus 2 over x plus 2 times x squared plus 1. Can we substitute in 2 now for x? So you have 2 minus 2, that's 0 in the numerator. But thankfully this time we won't get 0 in the denominator. Look, we have 2 plus 2, that's 4. 2 squared plus 1, that's 5. As long as it's not 0 in the bottom as well, we're good. 0 over some non-zero number is 0. So that's the value of our limit. Beautiful. Just one more. I feel like we've factored our little hearts out in this recent series. So we have the limit as r approaches negative 1 of r squared minus 3r minus 4 over 4r squared plus r minus 3. Why don't you pause the video, give it a try on your own. Did you pause it? Did you get 5 over 7? Oh, good. Okay. If not, it's okay. Here we go. Limit r approaches negative 1. The numerator is going to factor into r minus 4 times r plus 1. That one's pretty straightforward, yeah? And then here, okay, we've got 4r squared plus r minus 3. I'm just going to do trial and error, guess and check. I know. I said usually it's the ones that are closer together. Why didn't I do 2 and 2? Because this is a 4 and this is a 3. Since this is only a 1, I had a feeling like the 4 and the 3 were going to come into play. So 4r and r, and then if I put the 3 here and the 1 here, that's going to give me 4r, 3r, Yep, as long as this one's negative and this one's positive, we should be good to go. If you're like, Professor V, that was never going to happen for me, that's fine. Let's do the AC method. So A times C, 4 times negative 3, that's negative 12. B is 1. So two numbers that multiply to negative 12 and add to 1 for negative 3. So then we write this as 4r squared plus 4r minus 3r minus 3. Factor by grouping now. So take out 4r, r plus 1, minus 3, r plus 1. Don't forget to switch the sign. And then boom, 4r minus 3, r plus 1. The nice thing with the AC method is it always works, right? So long as your trinomial is factorable. R plus 1 cancels no matter how you slice and dice it. So then we have the limit. R approaches negative 1, r minus 4 over 4r minus 3. Good? Okay, so then now let's substitute in negative 1 for r. So negative 1 minus 4 over negative 4 minus 3. So that's negative 5 over negative 7, which is positive 5 over 7. Woohoo! Good job. How are you doing? Do you feel more comfortable with factoring now? So in the coming weeks, I'm going to be making more algebra review videos and then show how they integrate into the calculus that you're learning throughout the semester. Next topic we're going to focus on is simplifying complex rational expressions. So stay tuned. Make sure you don't forget to give this video a thumbs up, subscribe, and turn on your notifications. That way you know anytime I upload a video. And also follow me on Instagram and TikTok, Math with Professor V, so you can see what I'm up to. You can see little snippets of my work and just stay connected. I hope you guys have a great semester coming up, and I'll be back